Today I'll be demonstrating the Propeller platform's drone data visualization features and functions. I am using a landfill site for this demo, but any of the features I'll be showing you can be applied to any other type of work site, such as mines, quarries, and construction sites. We will start with a map, which as you can see is in 3D. You can zoom in to view any part of the map in detail. Now I'll zoom back out so we can find a stockpile to measure. I just click on the polygon tool and zoom back in to click around the edges of this stockpile here. If you can't see all of the edges, you can use the 3D view to navigate around and complete the shape by double-clicking back on the first point. We will call this one Stockpile 1. And you can see on the information panel that it has calculated a volume of 22,224 cubic meters. You can also view the volume in 3D. You can save these measurements on the left-hand side as a template to create a consistent set of data on any other stockpiles you want to measure. First, I'll add some additional data by clicking on the Add Edit items here. I'm also going to remove some of the irrelevant information like elevation, horizontal, or surface areas. Now I'll create a drop-down list and we'll call this list Material Type. And we'll call the items Topsoil, Cover Material, and Waste. And then save it. And now we can save the template, calling it Material. And now we can select the material type for this stockpile. This one we will call Cover Material. So when we measure another stockpile, we can use the same template. I'm using the polygon tool again to mark out the edges of the pile. And we'll call this one Stockpile 2. We'll use the same template as before and select its material. This one is also Cover Material. If we want to change the color of the volume, we just click the dot here and select another color from the list. Let's select orange. If you want to use the same polygon boundary to compare the stockpile volumes over other surveys to see how much the volume is changing, we just click here to promote the volume measurement to site level, which will make it available over all your different flights and use the same boundary so you know you are definitely comparing apples to apples when you are doing your stockpile volumes. We'll add one more stockpile, this one here. I'll add the tonnage of this stockpile by just clicking this weight symbol and changing the drop-down from Calculate Density to Calculate Tonnage. If you know the density figure for that type of material, you just key it in here. We'll use 1.2, which results in 1,600 tons. Once you have created the stockpile volumes, you can export all this data into an Excel report by clicking this button here. We'll just load it in Excel, and you can see the descriptions for both those stockpiles as well as the tonnage for the small one. I'll just widen these columns so you can see the full figures. You can see this description that says cover material. The smart volume showing 22,000, and the smaller stockpile showing 1,380. And also shows the tonnage down here as well. We can also use the polygon volume tool to work out how much airspace we have left in the landfill cell here. We just click the polygon tool again and mark out the boundaries of the landfill. We'll call this one Volume Check. This time, instead of Smart Volume, we'll do a Volume Compare, and we'll select the design surface to compare the volume against. This now uses the fill amount to show you how much airspace is remaining. Here, you can see it's just over 600,000 cubic meters. Now, I've intentionally made the boundary short so you can see the design and how it's calculated the difference, and how close the current surface is to the design. Those red areas are where there has been overfill, so you can work out if it needs to be taken out or if it is expected to settle back under the design surface. Another way to see how things have changed over time is to do an elevation check. First, I'll turn the display for that volume off to make it easier to see what I'm doing. Then I just click on the pin button and then click on a point to see how high it is. Let's call it Height Check. It now displays an elevation of 94.4 meters and a graph showing changes over time and against design. I can spin out the graph under the map so we can get a better look at it. This first point is the design surface, so we know we've got that amount to go. And this is how things have changed over time, including, as you can see here, how the landfill has settled over this period, which is good. Now, if we want to see that as a cross-section, we can just use the line tool and draw a cross-section across the center here. This gives us the length and the surface length, so you can also use this as a distance measuring tool. As we scroll down here, we have a cross-section graph, which I'll again flip under the map. You can see the point on the graph follows the surface on the map above it. Down this end, it looks like we have 3 meters to go before we hit the top of the design. As we go along, it becomes 6 meters. Right at the middle there, we have 20 meters of fill. You can spin the map around to see how the cross-section follows the topography on the map. You can see where it's flat, comes up, goes across, down, and you can see where we are hitting design and a little where we are over design at the edge. If you want to see what it was like last month, you can just clear the design surface, and let's see what it was on December 1. As you can see, not much has changed. In fact, it has settled a little. If you want to see an active cell, we can do exactly the same down here where you can see some trucks. So you just use the line tool again to go across the cell. And we'll do exactly the same thing. Spin it around in 3D. Again, you can see over here we have hit Design, with a small amount of dirt has been pushed over here, and there is still a fair bit of airspace to go in the middle. If you want to see what it was like last month, we'll do the same as we did with the other cell by removing the Design cell and adding the December 1 survey. You can now see where that dirt has been added, and then you can see that it was 2 meters lower in December than on March 14th. Towards the middle of the cross-section, you can see this little stockpile here appears as a dump that hasn't been pushed off. And then past that, you can see the 3 meters difference again. Another way to check what has changed over time is this timeline feature. We'll just click the Timeline tab here. Using this area here, we'll just first hide the cross-section we just created. Now we can drag the timeline to look back over time, over the different flights, to see what has changed over time. Back to December 6, December 1, November 1, and finally, all the way back to the previous December. So now you can see how things in particular areas have changed, which is very useful for keeping an eye not only on what you have done, but also on any contractors you may have working in particular areas. Everything you see on the map can also be shown as contours, just by turning on the Contour Map layer. And you can use the Timeline function to see how the contours have changed over time. You can turn it off just as easily to go back to the orthophoto view. The Inspection View pane is very useful for checking the detail of the surface or any objects on the surface. If I click on any spot on the map, I'll get a high-resolution image of that particular spot on the inspection view, which I can zoom right in and have a look at exactly what's going on. This is very handy if you want to do some environmental work or environmental checks. You can zoom in and we can look at this particular point. If we want to show someone there is something wrong here, we can put an annotation on it here. And we'll name it Check Pump. Same with the fence line. We can zoom right in and add an annotation. Let's call it Check Boundary. And we can also change its color. If you want to create a report out of these, we just click on the Render Annotation Report to PDF button. And it will give you exactly what you've just done. You can add a description to the report. Add the elevation. So the tool is really good for checking things really closely and inspection work. Some of the other tools we can use are slope and elevation. So if we want to see what the angle this slope is, we just click at the top, click at the bottom, and just call it Slope Check. What that gives us is not only the length and surface, but also what gradient it is. As you can see here, it is 12.5 degrees, and we can spin that around. If we want to see that slope in a different kind of ratio, we can change the settings to show it in percent, or we can change it to ratio, so it's a 1 in 4.5 slope. The same can be done for haul roads. To make sure you have the right slope on your roads, you just use the line tool and click along each section of the road you want to check, just as I'm doing here. And it gives us the grade for each of those sections. So I just click on Gradient, and it will tell what the slope is there. And if we want to, we can show it in percent. If you want to know the height of this landfill, use the line tool to click on the top of the landfill, click on the bottom, and we'll call it Height 1. Then, if we just click on Elevation, it will display the height. It's showing the top at 95.13 meters and the bottom at 72.96 meters, and it also shows the difference of 22.19 meters here. It's a real easy way to check heights. You can export the data in multiple formats, so it can be used by any other CAD package. You can see the file formats that can be exported. Digital elevation model, DXF, in 3 different file sizes because the full dataset can be very large, as you can see here. We can also turn on camera positions to see how the flight was flown. These are each of the individual camera positions from the drone. You can see it all in 3D still. We can turn on the point cloud to see where each individual point was created. You can zoom right in, and there is the actual point cloud for the data. Normally, a survey would have a point every 10 or 15 meters when you were doing something like this. I'll use the line tool to measure the distance between the points here. .15. So every 150 millimeters, there is a point, which makes the drone data really accurate and really powerful. You can also share this data with anyone via the Propeller platform viewer. First, we'll turn off the point cloud and the camera positions, and turn the orthophoto layer back on. We can share by simply inviting anyone with an email address. They'll get sent a link to the website, and you can give them different permissions. We've got View, Edit, and Manage. The View access lets them only view what you have done. Edit allows them to make annotations or take annotations away. And Manage lets them share the data and have full access to the site. That takes us to the end of today's demonstration. If you have any questions, just post them in the Q&A section on the web page you are viewing this from. And if you are interested in discussing how the Propeller platform could be used on your sites, get in touch using the Contact Us form.